Everybody, this is your stats practice final exam. You can get this PDF in Canvas. Um, it's just a practice final exam. It should be a PDF that you can either download and open up right now so you can follow along, or you can print it out so that you can follow along. Either way, I'm assuming that you can see the questions that I'm talking about. This video is only for problems 1 through 16. There'll be another video for another bunch and probably a third for the last bunch. There are 44 problems total on this practice final. So for number 1, they give us a frequency distribution and they want us to come up with a cumulative frequency distribution. Cumulative means that we're adding up a bunch. So if I take the height, again in inches, and it's cumulative. The first height is going to be, we say less than 72. And less than 72, there are only 16. Next up, less than 75. So that's going to be the 16 plus the 22, which is 38. You don't need to write the 16 plus 22 in if you don't want to. That's just me showing you how to get these numbers. Less than 78. It's going to be 16 plus 22 plus 15. That's going to be 53. Less than 81. It's going to be the 16 plus the 22 plus the 15 plus the 14. Gives me 67. The last one, less than 84, is adding all of them up. 16 plus the 22 plus 15 plus 14 plus 13 is going to give me 80. And again, you can just write in 16, 38, 53, and so on, all the way down the bottom like that. That's problem 1. Problem 2 has a bunch of data that I've actually already put in my calculator to save us a little bit of time. So you may want to pause this video so that you can put those numbers in. And they want us to construct a frequency distribution, and just a couple of reminders. I put the data in stat list, and here's my list 1. Yep, that is not my list 1, that's my list 2. List 1 is here. And you can see 91, 71, I'm putting them across. To make, and by the way, I'm going to ignore the lower class limit of 60. I'm going to do this the way that I taught you in class, which is a little bit better. First thing I need to do is put list 1 in order from smallest to biggest. So what I'm going to do is quit out of this, hit stat, and you can see sort A. So I want to sort, the A stands for ascending order, meaning smallest to biggest. And I want to sort specifically, make sure I have this in frame for you guys, list 1, which is above the number 1. So I'm going to hit second and then 1, and that's my list 1. And that's going to sort it for me. So now when I go back in my list, you can see it's now in from smallest, and it'll go all the way down to the largest. And they want us to make 4 classes with this. And instead of the lower limit being 60 like they asked, I'm going to have the lower limit be 66, and we're going to make this as accurate as we can. And so if you remember, it's the, for the class width, it's the maximum value minus the minimum value divided by the number of classes. So in this case, my max value, a quick way to get to the bottom of your list is just to go up, is 91. And consequently, if I go down, it takes me to the top of the list, minus 66 over 4. So this, this frequency distribution table that we're making right now is not going to look the same as it does in the answer key, because I'm not starting at 60 like they said, I'm starting at 66. And that gives me 91 minus 66 divided by 4. And although we get 6.25, if you remember, we always round up. We want to make sure we have the classes big enough that we include all of the data. So our class size is going to be 7. And so we're going to have the score and the frequency. And I'm going to start with 66. And to get the next lower limit, I'm going to add 7. 66 plus 7 is 73. And adding 7 again is going to give me 80. And adding 7 again is going to give me 87. That's how I get the lower class limits. Now, how do I get the upper class limits? Well, if 73 is here, then what goes there is 72. If 80 is here, this means 79 goes there. And you'll notice I'm going up by 7 each time as well. So 87 is here, so that's 86. And again, notice I'm adding 7. So if I add 7 to that, that's going to give me 93. Now I'm going to look on my list. Yep, we're good. Looking on my list, so stat. How many of them are between 66 and 72? I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 9. In between 73 and 79, I have 1, 2, 3, 4, 5, 6, 6. And 80 to 86, I have 1, 2, 3, 4, 4. In 87 and 93, I have 1, 2, 3, 4, 5, 5. And there is our frequency distribution table. Very nice. Moving on to number 3. Number 3, we have, these are the mean highway speeds that are summarized in the frequency distribution below. Find the mean. All right, so what we have to do is find the midpoint for each of these speeds. So to do that, I'm going to go 30 plus 39 equals and divide by 2. That's my midpoint. And I'm going to take each of the midpoints of each of the classes that we have here and multiply them times their frequency and then add them up. So the mean is going to be the first midpoint, 34.5, times the frequency, which is 5. And I'm going to do the same with the 40 and the 49, add them together, divide by 2. That's going to give me 44.5 times 18 plus 54.5 times 50 plus 64.5 times 17 plus 74.5 times 10. I'm going to be real careful here. So 34.5 times 5 plus 44.5 times, times 18 plus 54.5 times 50 plus 64.5 times 17 plus 64, so 74.5 times 10. Now that's just the numerator. That's all going to be over. And it says in the problem that there's 100 cars. So I get this number here, and I divide that by 100 because there's 100 cars. So what's the mean speed? 55.4, I think that's in miles per hour. Yeah. No problem. Number 4. Is we have 7 quiz scores, and I've already put this into my list, so you may want to pause it to put these numbers into your list. This is my list 2. You can see 55 and 18 and so on. So mine is in list 2, and so what I'm going to do to find the standard deviation is I'm going to hit stat. Put that up just a little bit so you can see what I'm pushing. Stat. I'm going to go to calculate. One variable statistics, and mine are in list 2. And if you remember the way you find the list, mine is above the number 2. So I'm going to hit second 2. And this one doesn't have a frequency list. Calculate. And my standard deviation is the SX. So in this case, it's the 19.7267. So the standard deviation is about 19.7267. Not too bad. Number 5. The mean height of a basketball team is 6 feet with a standard deviation of 0.2 feet. The team's center is 6'9" feet tall. Find the center's z-score, and is the score unusual? Remember, unusual means that the z-score is bigger than 2 or less than -2. So if you recall, z is the data point minus the mean divided by the standard deviation. The data point in this case is the 6.9. The mean is 6. Standard deviation, 0.2. So this gives me 6.9 minus 6 divided by 0.2. 4.5. And they ask, is his score or her score unusual? And the answer is yes, unusual. Because 4.5 is bigger than 2. So between -2 and 2 is considered a usual z-score. So let's flip this, get this into the shot. All right, number 6 is z again. So it says, which is better, a score of 92 on a test with a mean of 71 and standard deviation of 15, or a score of 688 on a test with a mean of 493 and a standard deviation of 150? Well, what we do is we standardize that, and we do that by doing a z-score. So there are going to be 2 z-scores for this one. I'll call it z sub 1. And that is a 92 minus 71. Same formula as before, x minus x bar over the standard deviation. Let's see what we get. 92 minus 71 divided by 15. So 1.4. We'll compare that to our second z-score, which is a 688 minus 493 divided by 150. $688 minus 493 equals divided by 150. 1.3. So a larger z-score means that it's further away from the mean, which means it's a better score. So in this case, 92 is the better score. So for 7, what we're going to need to do is put the data into our calculator again. I've already done that. So again, you may need to pause yours so that you put it in. And we're looking at percentile, which means this data set that in this case starts with a 12, then an 18 and a 42 needs to be in order. So I'm going to sort it again. So I'm going to go to stat, edit. And I want to show you list 3 is the data for this one. So mine's going to be list 3. So I'm going to go to stat again, sort. And once again, I want to sort list 3. So 2nd and 3 is going to give me list 3. Now it's in order. And I'm going to actually rewrite it in order. It'll be a little bit easier to see what I'm doing. So 6, 12, 12, 15. 18, 18, 24. 30, 36. 42. 54. 54. 54. 54, 66. That's it. Now there's a total of 18 scores here. And the problem says it wants to know what percentile the number 42 is. Well, 42 is the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10th location. And so I want to know how many scores are below that location. Well, if that's the 10th, then that's going to be 9. And I need to know what percent that is. 9 out of the 40. No, out of the 15. Nine divided by 15. And then times 100. I should write that in there. Times 100. That gives me 60. So it's the 60th percentile is the answer. So I could rewrite it like this. P sub 60 is 42. Meaning 60% of the data is below the number 42. Number 8. I actually don't need to type these numbers in because they're already in order. But I want to show you what I'm going to be doing. Let me share this screen with you. So you can see there are 40 scores here. This is 1 through 10, 11 through 20, 21 through 30, and 31 through 40. They want to know P sub 85. So what that means is I want to find the position that will guarantee 85% of the information is below it. So let me switch back real quick. So for this one, I want P sub 85, which means I need 85% of 40. So 0.85 times 40. 34. Now, if you remember in the lecture, when it came out to be an exact number like that, that was a problem. So this is the 34th location. Again, because it's a whole number, we're going to have to do a little wizardry here. Now the 34th position, if you remember, this was 21 through 30. So this is 31, 32, 33, and 34. So that 85 right there is the 34th position. Because it's exactly 34, not a decimal, it's not going to guarantee the 85% is below it. So what I'm going to do is I'm going to go to the 35th position, and I'm going to take the average of these two, the 85 and the 89, and that is going to be my piece of 85. So that means that I'm going to take the 34th and 35th. I'm going to find the mean. So that was 85 plus 89 divided by 2. So the answer is 87. This means piece of 85 is 87. Number 9, we have, and it doesn't say, but I want us to look for outliers and so on for this. Well, this just says do a box plot, but we're going to do the 5-number summary and everything. Just to, again, to save us some time, I've already put the data in here. And here we are. You can see the first one's 0.4 and so on. Now it's already in order, but what I want to do is I want to get the 5-number summary. That's going to give me, so the 5-number summary. That's going to give me the minimum, Q1, Q2, which is the median, Q3, and the max. And the way I can get those easily and quickly is I can go to stat, calculate, one variable statistics. And I've already forgotten what list that was in. List 4. So stat, calculate, here we go. So second 4 is going to give me list 4. And calculate. Here's the beauty. You don't see any of it here. However, if I scroll down, it gives me all of them. My entire 5-number summary. Let's use a different color here. So 0.4 is the minimum. Q1 is 2.1. Q2, or the median, is 3.45. Q3 is 3.8. The max is 7. And we are going to look for outliers. So I need to find the IQR. That's the interquartile range. So the IQR, if you remember, is Q sub 3 minus Q sub 1. So 3.8 minus 2.1. That's 1.7. So the lower fence is going to be Q sub 1 minus 1.5 times the IQR. So that's 2.1 minus 1.5 times 1.7. And none of our data are negative, so we don't have any that are outliers at the bottom. Let's try the upper fence now. That's Q sub 3 plus 1.5 times the IQR. So that's 3.8 plus 1.5 times the 1.7. Let me write that out. 3.8 plus 1.5 times 1.7, which gives us 6.35. So anything smaller than negative 0.45, which we don't have, anything bigger than 6.35. And when we go back to the data, we can see that we only have one value that's bigger than the 6.35, and that's the 7.0. So it is an outlier. So 7 is an outlier. And here's how we're going to handle this with the graph. So we'll say 0, 1, 2, 3, 4, 5, 6, 7. So let's throw down our outlier first. Use an asterisk. And now I'm going to put dots for these. I'll use green. So 0.4 is here. 2.1 is here. 3.45 is about here. And 3.8 is about here. Now, I can't use 7. It's an outlier. So what I'm going to do is I'm going to go back to the data. And I'm going to note that the next number that's below my upper fence is 4.2. So that's going to be my last dot on my graph, 4.2. So 4.2 is about here. And the way this is going to look, here's my box. And here's my whiskers. So there's our box plot, excluding the outlier. Now, the way that this is probably, this will go all the way up to 7. And I don't think they've calculated the outliers, but I want you to find the outliers. All right, 10. Now we're to some probability. And if you struggle with probability, that is very normal. So don't be too hard on yourself. View this as an opportunity to get it right this time. And if you do it well, fantastic. 2 6-sided dice are rolled. That means my denominators right away are going to be 36, 6 times 6. What is the probability the sum of the two numbers on the dice will be 3? Now let's write out how many ways we can have a 3. We can have a 2 and a 1, or we can have a 1, 2. So there's only 2 ways to get a 3. How does that translate for us? Well, the probability of rolling a 3 is going to be 2 out of the 36. And they don't really tell us if they want that reduced or how they want that. I'm going to put it into a, let me round it off. So that'd be 1 over 18. And 1 divided by 18. So it's about 0.0556. All right, for number 11, we have a spinner has equal regions numbered 1 through 15. What is the probability that the spinner will stop on an even number or a multiple of 3? So the probability even or multiple of 3 is going to be the probability of even plus the probability of a multiple of 3 minus the probability of even, I'll say and, multiples of 3. And to see this clearly, I'm going to write out 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So let's start with the even ones. I'll circle in blue. There. It looks like I have 1, 2, 3, 4, 5, 6, 7 of those. So probability of even is 7 out of the 15. Next up, in red, I'm going to circle the multiples of 3. 1, 2, 3, 4, 5. So it looks like there are 5 multiples of 3. Now we have to subtract the double counted ones. How many double counted ones? That's the one with the color on both. So there's 2 of those. So that's 12 minus 2 is 10 over 15. Reduce 5 out of that, that's 2/3. Which if I divide that out, I divide that out, 2 divided by 3 is going to be 0.6 bar. And it doesn't say. Okay, so we'll do 0.6667. Or 2/3. They might have 2/3. Both are equally correct to me. All right, we are to number 12. A sample of 100 wood and 100 graphite tennis rackets are taken from the warehouse. So that's 200 tennis rackets. If 7 wood and 14 graphite are defective and 1 racket is randomly selected from the sample, find the probability that the racket is wood or defective. So the probability that it's wood or defective. And we'll find this by finding the probability that it's wood plus the probability that it's defective minus the probability of wood and defective. So my denominator is going to be 200 because it's out of 200 rackets. So how many of them are wood? There are 100 out of the 200 are wooden rackets. How many of them total are defective? That is 7 plus 14, that's 21 out of the 200. And how many of them are defective wood rackets? There's 7 of those. So that's going to be 100 plus 21 minus 7. 114 out of 200. And let's get a decimal approximation with that. Divided by 200. So 57% chance that if you randomly select one, you get either a wood one or defective or both, is how we would read that. Number 13 is going to follow the same type pattern. So here we have described smoking habits of asthma sufferers. And it's broken up into non-smokers, occasional, regular, heavy smokers, and it's broken up into men and women. It says if one of the 1,111 people is randomly selected, find the probability that the person is a man or a heavy smoker. So for number 13, probability man or a heavy smoker. Well, that's going to be the probability that's a man plus the probability that they are a heavy smoker minus the probability that it's a man and a heavy smoker. So let's start here. How many men are there? The denominators are all going to be 1, 1, 1, 1. So how many men are there total? It looks like 5, 5, 8. How many heavy smokers are there total? 67. And how many heavy smoking men are there? Heavy smoking men, that's 37. So we have 558 plus 67 minus 37. And again, it doesn't say how they want the answer written. So if they want a fraction, you can put a fraction, or we can divide it out. I'll go to 4 decimal places, 0.5293. Number 14. In one town, 44% of all voters are Democrats. If 2 voters are randomly selected for a survey, find the probability that they are both Democrats. So probability, both Dems, Democrats. Well, they both equally have, they're both 44%, which we would normally write this as 0.44 squared. So what's the probability that both would be Democrats in this particular town? Be about 19% would be the chances of you randomly selecting a Democrat. 2 Democrats in a row, pardon me. Number 15, you are dealt 2 cards successively, that means without replacement, from a shuffled deck of 52 playing cards. Find the probability that both cards are black and express your answers. So this time they want it as a simplified fraction. So probability, both black. Now, you can have a picture of the cards if you're not familiar with playing cards. There's a total of 52 cards. And for the first one, half of them are black. So 26 out of the 52 are black. Now, since we're not replacing, there are now 25 black cards out of the 51 remaining. And I want us to be careful here. I'm going to use parentheses. 26 times 25, close parentheses, divided by parenthesis, 52 times 51. Now you'll note I got a decimal answer and they specifically want a simplified fraction. Here's how you do that. I'm going to hit math. I'm going to convert it to a fraction. Kind of cool, huh? That's the closest this calculator has to a fraction key. 25 out of 102. All right, and the last one for this video is a bin contains 64 light bulbs, of which 10 are defective. If 5 light bulbs are randomly selected from the bin with replacement, find the probability that all the bulbs selected are good ones. Now, how many good ones are there? Well, if there's a total of 64 and 10 of them are not good, that means that 54 are good. And this says with replacement. So after they take the light bulb out of the bin, they put it back in the bin. So that's 54 out of 64 times 54 out of 64, because we're replacing it. which is of course 54 or 64 squared. I hope that helps. So the remaining ones will be in another video that'll probably have a link right next to this video. So thanks, hope to see you there.